Welcome to another edition of RCE. Again, this is Brock Palin, and I have with me Jeff Squires from Cisco Systems, OpenMPI, and also HWloc, which happens to be our topic today.
Yeah, we're kind of cheating on this one, aren't we?
Yes, a little bit.
We're interviewing one of the other developers from HWloc, even though I'm one of the developers too. But if anybody looks at the Subversion commit log, you'll see that this guy has written a whole lot more of the HWloc code than I have. As a matter of fact, I believe it was part of his thesis work and whatnot. I've been doing, ancillary build system, configure system, and he's been working on the heart of it. So he can speak much, much more intelligently about this stuff than I can. So we're cheating, but only sort of.
Well, before we introduce our guest, we have a website, RCE-cast.com. There you can nominate new shows, pick up old ones, subscribe to iTunes. There's an RSS feed. So please stop by there and pick up any back shows.
Of course, I gotta throw in the plug for my own blog, the MPI Bcast blog out there. That it's on blogs.cisco.com, and there's a link off the RCEcast. And I try to get about one entry a week out there, and I try to say something at least nominally interesting. Last week I talked about traffic and my favorite acronym that I'm trying to get people to use, NUNA, Non-Uniform Network Architecture, because it's all about the networks these days. There's networks inside the servers, right? So it makes it more complicated. It's good stuff. NUNA. Start using it in casual conversations.
Well, actually, the software package we're talking about today, HWloc, is for kind of understanding the topology inside of a server, I believe. So let's go ahead and introduce our guest, and he can give us a better idea. We have Samuel Thibault, who's from France. So, Samuel, how about you introduce yourself, say where you work, and how you got started on HWloc?
Yeah, sure. So I'm a researcher in Bordeaux, between the university and the INRIA Institute. I'm working mostly on runtime support for parallel machines, and so be it multi-core or accelerator based. So that's why I was interested in topologies and locality in machines. On a side note, I'm also a Debian developer focused on the accessibility topics, in particular for blind people.
So I feel compelled at this point to say that the standard disclaimer that we're ugly Americans and we're horrible at pronouncing other language names and so on. So, Samuel, can you pronounce your name as you say it? Because I'm quite sure that we're not saying it properly.
In French, we say Samuel with a U, which is difficult to say in English, indeed.
Okay, we'll try, but I can't promise.
No problem.
So, Samuel, can you go ahead and give us a rundown of what HWloc is? We just mentioned NUNA and networks, and just give us a 10,000-foot view of what HWloc is and what it does.
Sure. So it's actually a set of tools to detect how HPC components relate with each other. So how processors share cache or memory, network boards, etc., things like this. And then tools to bind HPC applications accordingly. So it doesn't provide the intelligent part of the mapping, etc., just the portability of the tools to actually discover and pin things around, although we do provide some examples for people to get inspired from.
So actually, let me extend that definition just a little bit. I think this is actually more wildly applicable than just HPC. I think there's quite a lot of applications in enterprise and elsewhere that, as we're going to more and more cores in a system, they actually care about this stuff. And so I think this is not just an HPC kind of thing. I think this is where we're going to cut our chops and make our name, but I think it's going to be wildly popular after that. Just my opinion, though.
Yeah, I mean, modern machines now, you're looking at 48 cores and like a regular 2U server, so it's getting kind of crazy. So, Samuel, can you give us where the name for HWloc came from? I guess this is an interesting story.
Well, it's actually a very long story. The thing is, at the start, during my PhD, I was thinking about lib topology simply. The thing is, there was another lib topology that existed afterwards, so we had to change the name, and we had a lot of discussions. We can find on the list and on the wiki the various names we invented, some very difficult to remember, some very difficult to Google, and eventually we thought that just hardware locality, abbreviated into HWloc, does Google quite fine, and well, it's good enough for what we needed.
So why exactly, I guess, Jeff, you could probably answer this question too, because you've wrote a number of blog posts about this. Why is hardware locality and process affinity important in modern systems?
So mostly from our part, we believe the important thing is portability of performance. For instance, HPC libraries like to bind threads to get better performance, but they need a portable way to do this because it's not standardized. So HWloc does provide it. More than that, you need to be aware of the architecture of the machine, because if you consider it as a flat set of CPUs, then you would get congestions on the links between processors. So it's better to split and distribute the application according to the underlying machine. So be it for communication between processors, or spin-locked strategies, talking with network boards, things like this.
So I'll give another disclaimer here. I think I'm going to go back and forth between being interviewer and interviewee. So everything that Samuel just said, let me add just a little bit more on that, is that with these more and more cores in a machine, what is easy to forget is that there's actually a network inside that machine. And if you're not careful, most people don't think too much. When they're writing an enterprise class application, they just write their application. They don't care, and it gets some baseline performance. And if they need to, they optimize it a bit to get to the performance to where it needs. But with these larger and larger machines, it might be pretty easy to shoot yourself in the foot performance-wise because you're not careful and you don't realize that there's actually communication going on just in writing a normal serial or even a multi-threaded app. And that communication could get pretty intensive, and you could be really hurting yourself or hurting the overall machine performance if you're not aware of the locality of your processing and the locality of your data. And so, HWloc is really all about making the topology of the machine available to the programmer so that they can make some intelligent decisions about, how are they going to run and how are they going to, organize their data locality. It's just like real estate. It's location, location, location.
Yes.
So does HWloc just give you information about topology, or does it actually give you the functionality to do affinity?
Well, it does both. The thing is, it separates the two notions so that applications can just sit between the two and decide according to what they need. The problem is that you cannot really build a tool that, say, distributes your application over a machine because it doesn't know how the application is structured. So that's why hardware locality provides the structure information, lets the application do whatever interesting heuristic for the between the application structure and the machine, and then use the tools provided by HWloc to actually enforce some binding or some strategies for communications.
So what kind of information about the topology does it give you? Is it just the number of cores and which cores share a socket, or does it give you more information than that?
Well, the basic information that I wanted to put into it when I first designed it was to provide the tree of objects in the machine. So basically the base structure for it is a tree of objects, be it NUMA nodes, sockets, caches, things like this. And then there are some attributes, for instance, the cache size or memory size. And then from that structure, you can, for instance, enumerate the number of sockets or know which cache is shared between two processing units and things like that. So the idea